officer for Azure Cloud. So, so just some changes there. So, but yeah, it's been a pleasure. Thanks very much for the lovely introduction, and just looking forward to really meeting with the group and just answering questions and just having interesting conversations about Azure and Azure security. So I won't go ahead and I won't reintroduce myself, so it's exactly what Bill said about me. So no, I'm very passionate about Azure. I do Azure every single day. My wife has to seize my phone on weekends to prevent me from doing Azure on weekends also. So yeah, so as Jason, sorry, apologies. As Bill mentioned also, so I have 2 books that were just released on Azure. So penetration testing Azure for ethical hackers. I was actually looking at this about 2 days ago, and I realized that it was #1 in the computer hacking category, above the ethical hacker, the popular ethical hacker book, right? That popular ethical hacker book. So it was actually #1 for like about 15 hours before it went back to #2. So, but that was exciting to see. So I've also written another book on Microsoft Azure Security Technologies, which just focuses on the AZ500 certification. But as what Bill mentioned, my approach to technology is to try to make things as simple as possible. So that's the sort of approach that I bring to any material that I put out there. So enough about that. We're going to be looking at vulnerabilities relating to Azure today. And one of the things I like to mention is why I like taking this different approach whenever I talk about just security in general. So I like talking about the offensive side when I talk about Azure security, and there's a good reason for that. So there's a lot of content already out there on best practices. It's not as if we've had all the information that we need, but I think that there's a lot of information out there. You can go on Microsoft documentation site. You can go on YouTube and type Azure security best practices, and you'll find tons of videos by Microsoft, by people in different communities talking about best practices and that sort of conversation. However, you're going to find very little information about the offensive side of Azure security, right? So that's one of the reasons why I like focusing on that, because at the moment, there's less information around that. There's more when we talk about AWS, but less on Azure. So the other reason is understanding attacker behavior is definitely an important part of cybersecurity education. So it's important for us to understand best practices and how to configure things correctly, how to implement services in the right way from a security perspective. But it's also important for us to understand the mindset of the attackers. What tools are they using? What techniques are they using? What approaches are they using? How are they evolving that, right? I like the way someone sort of put it, like said, if the threat that you're facing is evolving, right, and you're still using the type of security that people were using 10 years ago, however, the threats that you're facing have evolved, right, no matter how great your techniques are, it's not going to be a match for the kind of threats that you're facing. So it's very important for us to understand what's out there, what techniques are going on out there, so we can sort of evolve our approaches to that. So it's also important for us to learn from the failure of others, right? So whenever we, just recently, there's been lots of major breaches on the Azure cloud. Some of the things that I'm going to talk about are some of the lessons that we can learn from some of those breaches, right? So we've had ChaosDB, we've had Azurescape, we've had, oh my God, vulnerability. Detected or discovered by different security researchers. We've even had others before that from Checkpoint and other security researchers. So what can we learn from those, right? In terms of how much trust should we really be putting when it comes to the shared responsibility model? You know, there's all this whole thing about shared responsibility model. Should we really be trusting in full what a cloud service provider are doing in this case? So some questions around that. So when we talk about just talking about vulnerability in general, we're talking about something that's a weakness in a system, something that can be exploited by an attacker to deliver a successful attack. An attacker doesn't necessarily have to be a bad actor. It could be an ethical hacker. It could be a pen tester. It could be someone that works in the red team or purple team of an organization. it's really what weaknesses can we look to exploit, and in what ways can we look to exploit that to deliver a successful attack, right? Is what we're really talking about here. And that can be down to software flaws. Maybe that software flaws on the side of the cloud provider, maybe that software flaws on the side of the development teams that are putting and hosting application on Azure, right? So it could be down to unintended functionality. So it's something that it's actually working the way it should be working. However, there's been a discovery on how to use that functionality in a way that it was not intended to be used. So, and there are different sources for this. So we some of them are 0 days. They're publicly reported also by researchers that discovered them. So in many cases, especially when it comes to things like the public cloud platform, it's down to a feature misuse, right? Or a functionality misuse. So something that's intended functionality, but then it's been misused to do something bad, right? So a good example of that was I was looking at a document the other time of when people have like just IP allow list or maybe IP block list, and one of the ways that people try to block different types of attack, and then using the cloud to bypass those type of systems. So using the cloud to sort of generate attacks from different IP addresses, because it's the cloud, so I can generate an attack from East US region, West US region, and just spring to just sort of vary the regions where the attack is generated from to bypass different systems. So that's definitely an intended functionality of the cloud to be able to deploy into different regions, but then using that in an unintended fashion. So it could be down to just user error or misconfiguration also. So whenever I talk about Azure in general, I just like to quickly do a review of what the Azure organization structure looks like, because that helps us to understand why security in Azure is complex. Security in Azure is complex, so it is not simple. And there is a reason for that. At the top of the Azure hierarchy, we have the Azure AD tenants, where we have our identities, we have our users, we have our groups, we have our service principals, we have our managed identities, right? Service principals, which are application identities, managed identities, which are resource identities in Azure, which can be either system assigned or user assigned identities. But when we talk about users, there's a whole lot of complexity when we talk about users in Azure or users in Azure AD, right? So this could be just native users. This could be synchronized users from on-prem AD. This could be guest users that are invited from another partner's Azure AD. This could be external identities using their Gmail credentials to sign in. This could be just a federated identity, maybe coming from Okta or any other federated service. So many people don't really look into that in terms of federation that may be set up. I've seen scenarios where organizations set up conditional access to be able to allow to set up conditional access to be able to define the conditions by which they allow access to certain application. And to bypass that condition is as easy as switching to a federated identity and bypasses the whole security that they've configured, right? So sometimes, we focus on, native users of Azure AD or synchronized users from on-prem AD, but sometimes we ignore things like the federated users or external identities that we're bringing into our environment. So then we have, within the Azure Resources section, we have something called the Root Management Group. So the Root Management Group is sort of the top of the Azure Resource hierarchy. That's where organizations can apply policies that they want to apply across the entire organization. So you have the Root Management Group, you have the Child Management Group, and you can go up to 6 levels deep in terms of the Child Management Group. You can have your subscriptions groups together under Child Management Groups. And then you have your resource groups, and within your resource groups, you have your resources. One of the things that you see is that Azure AD has a separate RBAC structure to Azure resources. And that's where you begin to see where some of this complexity begins to come in, right? So Azure AD has different roles and different RBAC structure, roles like global administrator, user administrator, application administrator. Azure RBAC has a different RBAC structure where that you use to grant access to resources. So you have built-in roles like owner, contributor, and reader on that level. Now, as a good practice, you want to ensure that you're separating these roles from each other. In other words, if I have a user here called Joe, I do not want Joe's account to have access to Azure AD, to have administrative access to Azure AD, and at the same time, that account has administrative access to manage Azure resources. So that's a basic good practice, because that allows for lateral movement. Because that way, if Joe's account is ever compromised in what way, maybe a token, an access token is stolen from Joe's PC and then used to access the environment. If Joe's credential has access on these two levels, then it's easy for an attacker to move laterally across from Azure AD and then begin to access Azure resources, or maybe even move from accessing Azure resources to being able to open backdoors in Azure AD. So we want to be really careful in terms of how we structure our role assignments between these two RBAC services, or these two RBAC systems. So when we're talking about RBAC in terms of Azure resources, we have that's defined in JSON, and you find that in 4 sections, you have actions where you can define management permissions that you want to allow. You have data actions where you can define data plane actions that you want to allow. And then you have not actions where you can exclude management plane permissions, and you have not data actions where you can exclude data plane permissions. So there is no deny framework except you're using something called Blueprint. However, you can exclude permissions from what you've already added. So one of the places where you begin to see that complexity is in that permission structure there. So for example, here is the latest snapshot that I took from this website, azure.permissions.cloud. So it's a nice website that was built by Ian McKay. So Ian does amazing things in the security community. So Ian puts together this website where he's bringing in information from IAM on AWS, on Azure, and Google Cloud, and bringing them into this website, which is just permissions.cloud is the main website. But you can prefix that with whatever cloud that you're going to. So in that particular case, talking about like the Azure cloud, right? And if you have a look at that, have a look at that. There's currently about 13,440 actions that we can define when defining permissions in Azure RBAC. Now you can begin to see where some of that complexity is coming from, about 13,440 actions. And now multiply that by the number of users that you have to manage in a typical organization, right? Multiply that by services changing all the time and new capabilities and new actions being added all the time, right? And then have a look at all the different ways that some of these permissions can be misused. And then you can see why this is really, really complex for many people to handle. The other issue that you're going to find there is that there are about 317 built-in roles. And many cases when people see those built-in roles, many people build their IAM structure, they build them using the built-in roles. But one of the things that cover, when we talk about like pen testing in Azure, one of the things to know is that for many of the built-in roles, it's very easy to exploit some of the permissions that they have as part of the built-in permissions. So for example, one of the things that I'm not sure if Bill has seen that in the book, one of the things that we covered there is you have like a reader credential. What are some of the different options or different methods that an attacker could use to escalate privileges from reader to a contributor, and then escalate privileges from a contributor to owner of the entire subscription, right? So there are lots of permissions that can be easily exploited, and they can be really just taken advantage of to move laterally within the environment or to be able to escalate privileges within the environment. The other thing that also makes it very complex in terms of Azure security are the massive amount of services that we have in Azure. I think the last time I counted, I think there were probably about, let's go here. Let's clear the screen. I think last time I counted, I think we have about 179, something like that. Let me go ahead and just do a quick count of current Azure services. Right, there's a lot of them. There's this with use to count that. Let's go to Azure PowerShell and let's bring up some information here, and let's go to that. Okay, so typically just go to like the directory of Azure Cloud Services, and I just count the services there, count the unique number of the services that exist there. So what I'm going to do is I'm going to count all the services in the directory of Azure Cloud Services, and I'm going to remove any duplicate counts. So I'm going to use I do that using the unique parameter, and that's going to give me a list of all the services that are currently listed on this page. And if I do a count on that, that's about 177 services, right? That's a lot of services in terms of understanding how the services could be misconfigured, understanding how the services could be exploited, understanding what sort of ways that it could be misused, right? So that's one of the reasons why things are so complex in terms of managing that. Another thing that also adds to that is let me go ahead and bring up the slide that I'm looking for. Another thing that also adds to that is the cloud native approach, which is how many organizations deploy things to Azure these days. So let me go ahead and bring up the slide for this. So if you have a look at the cloud native security model, for example, which is how many organizations adopt the cloud and the way that they're deploying things, you have organizations having their code, and they have their code, and their code runs typically in a container, or if it's not running in a container, it's running directly on an online host. And the container or the code is running directly on a node, which has an operating system installed. So that could be Linux, Windows, that could be Red Hat, Core OS, if you're using something like OpenShift on Azure. And that node is managed by an orchestrator or managed by an Azure service, like maybe Azure Functions or Azure Batch or Azure App Service is managing the nodes. And then you have that service or that orchestrator running on the Azure cloud. And this is one of the other reasons why security is very complex in an environment like Azure, because vulnerabilities can be introduced at any of these layers into the environment, and they can be used to exploit the environment. It could be vulnerabilities introduced on the cloud layer or the cloud level that's exploited to be able to gain access to a service and then being able to compromise the rest of the stack. Or it could be vulnerability that's due to codes that's been deployed into the environment that's exploited to break out of the container into the node and now steal credentials for the cloud and then use that to move laterally into the cloud. So now you're not just talking about one security model that we have to understand. You're talking about having to understand about 4 or 5 different security models. You have to understand the security model in terms of application code, and understand security model in terms of containers and in terms of operating systems and in terms of orchestrators, which is a complete beast on its own. And at the same time, understanding security model for the cloud. So hopefully that just gives you like some quick information on how complex that is. So one of the things that Bill mentioned that I put together is around something called the Azure Attack Matrix. So one of the reasons why I put that together was because I didn't see anything that was really satisfactory. So what MITRE has out there, it's not bad, it's good. But looking at what I've seen in terms of my own experience, I don't think it's like as comprehensive as it could be. I have recommended some of the stuff for them. Also, MITRE used to have something dedicated for Azure, but then they removed it in favor of just going MITRE Matrix for IaaS. So what I started putting together a while ago was I started putting together things that I've seen in my own research, in other people's research, and I started putting that together in something called the Azure Attack Matrix, which changes all the time, which grows all the time, and just putting together different tactics and techniques that I've seen used in terms of discovery techniques, where an attacker is aiming to learn about a victim's environment, trying to identify the attack surface, trying to gather as much information as possible about a victim's environment and some of the techniques that you see used in that sense. And then talking about credential access and some of the different approaches that attackers use to get access to credentials in an environment like Azure. right? And there are different methods. That could be just guessing credentials in Azure AD. That could be compromising a node in the cloud that has an identity associated with it. That could be application credentials that's stored in configuration files or in the configuration sections of services like Azure App Service or Azure Functions. That could be down to just cloud service credential access in terms of what's been exposed, maybe in things like storage account or just data stores. And then methods that attackers use in terms of initial access. So this one is a new one that I added due to recent vulnerabilities in Azure. So cloud provider service vulnerability, because if you look at all those vulnerabilities in terms of ChaosDB and in terms of Azurescape, and in terms of, oh my God, all of these are down to cloud provider service vulnerability, where there was a vulnerability in the way that a feature was implemented in Azure that attackers exploited, and then being able to use that to move laterally into another customer's environment, right? So that could be exploiting anonymous access. So one of the things that I'll show you later in terms of the lessons learned, they're just about 3 services at least that I've seen exploited that support anonymous access in Azure. So, and in terms of how people exploit that could be a trusted relationship. Maybe you have like a private link built to another customer's environment. That could be through VNet peering. That could be on multiple layers, right? Not just like the network layer. That could be on the access layer in terms of trusted relationship, in terms of identity. So there's multiple levels of depth into that. That could be due to application vulnerability, still popular form in terms of getting initial access into the environment. That could be weak or default service credentials, typically with services like virtual machines. That could be cloud credential compromise, and this can take a lot of forms. That could be stealing cloud credential from a developer system. That could be stealing cloud credential from developer toolings like DevOps, tooling like maybe from Azure DevOps or from GitHub Actions or from other developer tools like that. Okay, so let me just move on very quickly in the interest of time. Okay, so and different approaches to perform execution, to do privilege escalation, and to evade the defenses, right? Evade defenses could be just modifying the IP allow list. One that I saw recently in terms of well, no, not defense evasion. So the one that's coming to my mind is in terms of persistence. So I saw one recently in terms of persistence where someone added an FTP credential to an Azure App Service, right, as backdoor. So I probably need to add that to that list. So somebody added like, so you have an Azure App Service in the environment, because Azure App Service allows you to be able to, it has a default app level FTP credential, but then you can have additional FTP credentials, but there's no way for you to have visibility of those credentials in the portal. And looking at the backend, they were seeing all sorts of credentials that's been added, which means somebody could FTP into the app environment and get access to source code, right? So you have all these different approaches that can be misused and leveraged. You have modifying allow list. Another one is using Azure policy as backdoor. So where exploiting things like guest extension for Kubernetes to force install a backdoor in Kubernetes that gives an attacker persistence into the environment. Even if you go ahead and remove something, Azure policy will ensure that it's put back there, right? And just leveraging that for backdoor. So there are multiple approaches that we're not going to be able to cover some of them today. But I'll just go ahead and just talk about a few of them, and then I'll talk about recent breaches and some lessons that we can learn from that. So in terms of discovery, that's can be from 2 approaches. That can be on authenticated discovery, where an attacker has no credential into the environment. They don't have any credential. They are coming at this from the perspective of a complete outsider, or that could be authenticated discovery. Maybe you're doing something like assume breach pen test scenario, where an attacker is given the reader credential to see what they can find in the environment and that. So when it comes to things like unauthenticated discovery, so typically, the normal type of, scan the IP address range, look for vulnerabilities that you can exploit to get into the environment, Or in this particular case of using DNS enumeration and using DNS enumeration to try to look for services in Azure that support anonymous access. As I mentioned, there are a few services in Azure that support anonymous access. And then if you find any service that supports anonymous access, using that to exfiltrate any data that you find in that service, hoping that you find some form of credential or some form of information that will be useful further in the attack chain later in that particular case. One of the tools that's really popular for doing both authenticated or unauthenticated discovery is a tool called Microbust. So Microbust was actually written by the person that we co-wrote the book together. So his name is Carl Forsyne. So Carl leads a group of pen testers out of Oregon. So Carl wrote this tool, which is a set of PowerShell scripts that you can use to perform different attacks on Azure. So it also includes a script that you can use to do DNS enumeration of services in Azure and then look for those type of anonymous access. So his name is Carl Forsyne, so that's his Twitter handle. GitHub repository for Microbus. It's an open source project, so anyone can really contribute to it. It's written in PowerShell. So I will show you a little bit of some demo of Microbus, but before I do that, let me just point out in terms of the Azure DNS suffixes that exist that tools like Microbus can scan. So if I go to, not this one, so not this one. Let's go to this one. Yeah, so in this particular case, so for many services in Azure, many platform services, you have the resource instance name dot the DNS suffix name. And then, so for example, if you have an Azure storage account called Azure Offensive, it's going to be azureoffensive.blob.core.windows.net. But you have multiple other services in Azure, like .azure website and stuff. You can find those. It's not a comprehensive list. I've not really seen where Microsoft has like a full comprehensive list anywhere. But if I do AZ Cloud Show, and I'll put that as stable, and if I do AZ Cloud, okay, no, that's AZ Cloud Show, yeah, AZ Cloud Show, and let's say the name of the cloud platform to show is Azure Cloud. So let's do that. And that's going to give like a list, but it doesn't give like a full list of the DNS suffixes of the services. And you can see this across all the different cloud that Azure has. So that's for the Azure public cloud. You can view the same thing for the Azure, let's say, Azure US government, for example. But again, it's not comprehensive. So I've not seen where Microsoft actually has like a full comprehensive list anywhere. So in case anyone knows of where you can find some, but you can go ahead and you can see some of those DNS suffixes listed there. And again, tools like Microbus can scan those. So what I have is I have an environment where I have some services. And if I go over to my virtual machine and I'm going to download Microbus, and let's see that in action. So let's discard that. Let's bring up my virtual machine. Oh no, do I not have, oh no. Oh no, okay. Let me see if I have this on my normal machine. If I have this on my normal machine, I'll just use that. Let me go ahead and bring up PowerShell on my system. Let me check that I have its module. Let me make sure that I have let me make sure that I have Azure PowerShell installed. So get module list available. If I have Azure PowerShell installed, then I can go ahead and just get Microbust from GitHub, and then I can use that. Let's minimize this. Come on. Okay, yeah, good. I think I've got that installed, so we're good to go. So what I'm going to do is I'm going to first of all just go get go clone. I think I've got Git installed. Good. So let's go to get Microbus downloaded and installed. and I'm going to import the Microburst modules. Once that's imported the modules, come on, you can get the modules. Oh, it shouldn't take that long. It's doing something. Come on. If that does not respond quickly, I can move on and I can come back to this later. Yeah, okay, it's not responding. I can see that it's doing something. I can see that it's trying to download, because I'm looking at the network monitor here. I can see that it's trying to download some things, but normally it shouldn't take that long to download. Okay, while that is downloading, let me just take you to the Microburst URL and just show you some of the, I'll just show you some of the modules that Microburst comes with. So typically, if you go into the AZ folder, you're going to see some of the modules there. You see some of the modules under the miscellaneous folder also. If I go to the AZ folder, you can see some of the modules here. And a lot of these modules are what you use for authenticated discovery. So you have some credential into Azure. So typically you have a reader credential, you want to do authenticated discovery, you can use those. But then you also have, if I go under miscellaneous, so this is where you're going to find some of the modules for doing on authenticated discovery. So for example, you have a module here for invoke enumerate Azure blob. So that's going to look for anonymous Azure blob. You're going to give it a base name, and the base name that you provide is going to scan that base name and check if it's going to find any anonymous blob using that base name. So that's something that you can also modify the permutation. So the permutation that is going to use by default is listed in this document right here. Let me expand that. Let's go to that. So it's going to use the permutations listed here. So for example, if you want it to, when it's searching, you want it to look for maybe a container name called something else, right? So you can go ahead and just put that container name there, and then Microbus will include that as part of the path that is going to search when it's trying to do anonymous listing. So unfortunately, it's still doing some type of download, and once it's finished, I can come back to show that to you. So so that's one approach in terms of doing just the discovery. When it comes to things like initial access, there are multiple ways that happens, right? So I'll just point out one of that. So it mentioned cloud credential compromise, but that could happen in multiple ways. So typically, it could be it's an attacker having the aim of the attacker is to try to get a credential that they can use to access the ARM endpoint of Azure, and that could be or also maybe just to access like the data plane in terms of the services. And there are multiple approaches that could be taken. So targets that usually maybe just doing phishing for user accounts in Azure AD, just looking for service principals on typically on different developer systems or DevOps services. And in many cases, just looking for access token that's been issued and cached locally on different services. And some of the methods are targeting user admins in terms of phishing, targeting DevOps systems, and scanning DevOps system with reader credentials, looking for variables that contains cloud credentials that has been exposed. So Azure DevOps, as a command line tool that if you have with the right level of permissions, you can go ahead and you can exfiltrate and export a lot of the credentials that people have in variables in their pipelines, right? So that could be targeting admin workstations. In this particular case, it's mainly looking to steal cached access tokens. Microsoft made an improvement to that recently in moving fully to MSAL instead of ADAL, which means that some of those tokens are no longer cached locally. So that there's some improvements there. So there's less options for an attacker to steal those tokens, right? That could be just targeting just Azure hosted applications, maybe through application vulnerability, because these resources can also be assigned an identity that where a token can also be stolen or exfiltrated and then used to access Azure ARM endpoint to do further recon, to do further enumeration of the environment using a credential now. So I'm looking at the time here, and I'll need to pause there in terms of some of this. So let me quickly go talk about some of the recent breaches or some of the recent vulnerabilities on Azure and some of the lessons that we can take from them. So let's look at, so a lot of all the ones that I'm going to be talking about here, they fall under the category of cloud service provider vulnerability. And my whole reason for doing this is to help us to understand how can we protect ourselves even if there is a vulnerability on the side of the cloud provider, like the three that happened, and how could we protect ourselves that even if that were to happen, there is less possibility that our environment will be compromised. So let's first of all go look at the first one, which is ChaosDB. So ChaosDB is the one that was discovered by some researchers from Wiz. So the way that the vulnerability worked was there's a feature of Cosmos DB, which then if you create Cosmos DB, it comes with Jupyter Notebook, and you can query data using code, and you can run Python and then query code and just do some fancy things with data just using code. So what the researchers did was they didn't just use Python, they were trying different languages, and they ran some C# code, and then they realized that C# code was running as root. If they run the code using Python, it was running with a non-sudo user, which was Cosmos user, but just switching to C#, it noticed that it was running as root, and then they use that root account to create another account that they can then use to look at the environment. So they used that to escape out of the container of the Jupyter Notebook, and then they started doing some recon on the environment, and they noticed that there were some explicit block rules in IP tables. And they noticed some explicit block rules that was blocking some IP address ranges. And typically, you work in security, if you see something that's explicitly blocked, you want to know why they're blocking that. So what they did was they used the root permissions to remove those block rules in IP tables, and then check the environment to see what they found. And eventually what they found was they found certificates that were exposed. So they began to query the internal metadata service, and they found some certificates that were exposed. And then they used those certificates later when they gain access to some internal systems to authenticate those internal systems. And the end result of that was they were able to get access to multiple database access key for thousands of users. So this was something not on the side of the user in terms of some of the other options. This was something on the side of the cloud provider that caused that, right? Another one that happened just a few weeks after that was disclosed was Azurescape. So this was discovered by researchers at Palo Alto Networks. So the guy's name is Yuval. So this is from an Azure service, which is Azure Container Instance. And what the researcher did was the researcher has a tool called UC. So it's a tool that I've blogged about in the past in one of my blogs. So if anybody is interested in testing out that tool and seeing what that tool is, if you go to davidokeyode.medium.com, I blogged about that tool called UC. So it's a tool that you can use to enumerate any container runtime environment. So very, very useful tool. So Yuval was the one that created that tool, but then he used that tool to essentially enumerate the runtime environment of Azure Container Instance. And what they found was that the environment was running an outdated version of runc, and there were known exploits for that version of runc that it was running. So he used the exploit of that CVE, and he used that exploit to escape the container, and now is on the node that it should not have access to. And then he began to do some enumeration of the environment and found that it's running Kubernetes, and it's running an outdated version of Kubernetes. So what he also did was he used another exploit, to trick a bridge pod on the node, and it essentially sends an exec to that bridge pod, and that bridge pod sent an exec to the API server. And in return, what it got was an exposed privileged service token. And then with that privileged service token, it can begin to move across to other nodes in the cluster. And other nodes in the cluster runs other customers' container workloads. So it was able to compromise other nodes in the cluster and began to run other and began to access other customers' workloads and even begin to run code on their container environment. So both of this has been fixed and patched by Microsoft, but I just thought there are some very interesting lessons to learn from them in terms of how, if this were to happen again, how we make sure that we are protected against something like this. So one aspect of it that I think is very important, I've seen this in my own experience also, is that we need to start normalizing private network access for platform services, right? So for some reasons, many organizations still have platform services that they're not using private access for. And I understand some of the reasons for that, right, from a usability perspective. So for example, I was looking at if you're using Azure Container Instance in a private network, I was looking at the limitations that it includes. You cannot use managed identities. You cannot use it with VNet peering. So just with those limitations alone, I can see why the development team may make the decision to say, we're going to use this with public access instead of with private access because we need all this other functionality. But wherever possible, we should have mitigations, even if we have to use something in the public way. But we need to start normalizing private network access. There are multiple ways to have platform services with private network access in Azure. So one of the common ways is to do something called VNet integration. So VNet integration is not supported by every platform service in Azure. And this is where you have a platform service, you deploy it into a private network, and then you can have ingress and egress traffic control of the virtual network applied to that platform service. So at the moment, this is supported by only about 23 platform managed services. So it's not supported by too many platform managed services. Many of those services are going to require dedicated subnets, which means that when you're doing your architecture, they cannot run alongside other services in the same subnet. So you have to have a subnet that's dedicated to that service. So a service like Azure Cache for Redis, SQL Managed Instance. So these services are going to require a dedicated subnet if you're going to integrate them in a virtual network. And some services also require delegated access. So delegated access means the service is going to require permissions to be able to create resources in your network. So some organizations can be a bit careful of that, especially if your network is also connecting to maybe your on-premises environment. And some organization may not like that. Someone that's not my team or something that's not my team can be creating resources in my environment. So for example, if you go use Azure SQL Managed Instance, Azure SQL Managed Instance is going to require permissions to be able to create network security group in your network. It's going to require permissions to be able to modify the root table in your network. So, you know, for in many cases, Microsoft has done a great job that they do not take more than the permission that they've listed in their documentation, but just be aware that some of them are going to require delegated access to your environment. So VNet integration is one of the ways that you can use to do that. If ChaosDB happened, which is Cosmos DB, where credentials were stolen, and VNet integration was implemented, well, VNet integration doesn't work for Cosmos DB. The other one works for Cosmos DB. But if private network access was implemented, an attacker would not be able to gain access to the data. So they will still need to go through another level of the layer of defense before they can get to the data of the customer. So another option to implement private network access for platform services is to use private endpoint, which just means you link that platform service to a private network. And the downsides to this compared to VNet integration is that this only affects ingress requests. So requests that's going from your services or from your workloads into those services, not traffic that's coming out of those services. So this is only this is for ingress only. But again, in the case of Cosmos DB, if this was implemented and public access was blocked, even though the researchers had the access keys, they would not be able to access the data, except they can compromise the network also and gain access into that network, right? So another option, which is at the minimum, is you want to make sure that you at least restrict the IP addresses that your platform services can be accessed from. So at the minimum, you want to restrict that to trusted IP addresses so that even if the credentials were stolen, it's something that you still need to compromise, you know, the trusted network to be able to use. So you can use this in combination with private endpoint and then you can have it that way. Another important lesson is to disable key-based and local authentication where possible. Azure Services supports a range of authentication and authorization options. We have some services that support anonymous access. Some services support key-based authentication. So typically that could be long-lived access tokens or temporary access tokens. Like in the case of Azure Storage, it supports long-lived access token. It's a 512-byte access token in terms of the access key, but you can also generate temporary shared access signature tokens that you can use. Some services support identity-based authentication. So that could be local authentication in the case of a service like Azure Container Registry, or that could be something like Azure AD in the case of Azure File, and Azure Blobs would support Azure AD, and even Key Vault supports Azure AD. So you have to understand the services that you're adopting and understanding the type of authentication and authorization that they support. In terms of anonymous access, services, the main ones that I've seen exploited are services like Azure Blob Storage, Azure Container Registry. So Azure Blob Storage Container can be set to have anonymous access, and again, tools like Microbus can be used to scan and discover those in an automated way, and even exfiltrate data from them in an automated way. So services like a service like Azure Container Registry can also be set for anonymous pool. So typically organizations that do this, I've seen where people set that to be able to do some tests and then forgot to remove that. So, and the only information that an attacker needs to be able to exploit that would be to be able to guess the name of the registry and guess the name of the container. If both of those unknowns can be guessed, then essentially they can pull down the container image. And it's not unusual, I see that on a regular basis. It's not unusual to find a credential hidden in a container image. Even though it's not good practice, it's still something that we still commonly see, right? So again, information that's needed for external attack, in this case, you need information about the resource name, information about the container, or in some cases, you need the object name. If it's for the container, you need information about the repository and the image name. And again, both of those information, you can use a list or guessing, it just put like a permutation list in tools, again, like Microburst or Lava, and then you can use them to be able to guess those. When it comes to anonymous access, for those two services, you can disable anonymous access on a per resource basis. So you can disable that for Azure Blob, you can disable that for Container Registry, but you can also disable it centrally using Azure Policy. So Microsoft has some policies in preview that you can use to check if, what's it called? If public, well, this is not public access actually. So the one that we're looking for is key-based, this anonymous access, yeah, if public access is allowed. So they have like a policy in preview that you can use to check that on a central basis across your entire environment. So you can leverage that. So the other authentication option, which is long-lived access keys. So this is supported by about 28 services. So in terms of the count, I think I'm going to come out with a blog in terms of, because I did a detailed count and looked at the different services and looked at what can be done. So there are about 28 services in Azure today that support long-lived access keys, which are access keys, authentication, and authorization. So services like storage account, of course, it has 2 access keys. Services like Cosmos DB also has 2 access keys. Compute services like batch account, service fabric cluster, Signal HAL, AI services like cognitive service and board service, data services like Data Factory, developer services like app config. All of the services and others support long-lived access keys, which means you have access keys that can be used to authenticate outside of the central identity control plane. So, and the access level that the access keys grant, it ranges from unrestricted management or data plane access. In the case of Cosmos DB, with the ChaosDB issue, read and write keys will give unrestricted both management and data plane access to that. So, and it's the same for Azure Storage access keys. So unrestricted management and data plane access. In some cases, some of the keys are just data plane permissions only. And in some cases, they're just read-only data plane permission. For example, in Cosmos DB, you have read-only keys that you can use just for read-only access in that particular case. I'm not going to go into the other one in details because I'm looking at the time. So there's a lot of information that we could cover on some of the behaviors of some of these long-lived access keys and some of the differences between them. But I'm looking at the time, and I'll just skip some of them. So when it comes to local authentication, there are some services that support local authentication. Of course, virtual machines support local authentication, but there are also platform services like Azure SQL Database, Azure SQL Managed Instance, Container Registry. They support that. So the good thing is that you can disable local authentication for both Azure SQL and Azure Container Registry. So Azure SQL, when you first of all create a database, it has something called an admin user. The admin user has access to all the database within the service, including the master database, right? So that is a user account that, if not disabled, then someone with the right level of permission can reset the password of that admin user and use that to access all the databases in that service. So there is a way to disable that. So you can disable admin user so that you only use Azure AD authentication for Azure SQL. Same thing for Azure Container Registry. There's an admin user that you can enable. It's disabled by default, but it can be enabled maybe maliciously as a backdoor into the environment, or maybe somebody enabled it and forgot to disable it. You can disable it individually, or you can enforce disable using Azure policy. So there are policies that you can use for Container Registry to disable local authentication, for Azure for Azure SQL to ensure that only Azure AD authentication is enabled, right? So good practices when it comes to this is you want to disable long-lived local authentication, long-lived access key, or shared access signature generation where possible. Where possible, stick using identity-based authentication, especially just going through Azure AD because of the powerful identity security capabilities of Azure AD. You also want to monitor for configuration status changes. So if somebody maybe compromises a credential and they enable the admin user for your SQL database, or they modify the configuration to enable admin user for your container registry, you want to monitor for that so that it flags an alert so that you can see that that's been changed. You also want to monitor events for usage of local authentication, long-lived access keys, SaaS generation, or anonymous access. So you want to monitor your resource logs for that. I was going to show you some of that, but I'm looking at the time now and it's a bit late. So I believe that I wrote a blog. About anonymous access, and one of the things that I highlighted in the blog is how you can sort of enable the resource logs to be able to check that, and what the logs looks like and what you can see in the log. So, and the same thing, I'm going to put the same thing out for local authentication so you can know what to look for in the logs. So if you're looking at the resource logs for anonymous access for storage account, you'll be able to find that once you enable resource logs. You'll be able to find under the identity section, you see that the type of access is anonymous, and then you can flag that if that's happening in your environment. So where not possible to disable, do the following. So in some cases, it's not possible to disable that. So for example, if you're using Cosmos DB and you're using the SQL API of Cosmos DB, the SQL API of Cosmos DB supports identity-based authentication with Azure AD. However, except something changed recently, the other APIs of Cosmos DB, the Mongo API, the Cassandra API, the Table API, and the Graph API, they do not currently support Azure AD authentication, which means you still have to rely on key-based authentication. In those particular cases, you want to make sure that the keys are stored in key vaults. You want to make sure that you regularly rotate them. Unfortunately, Microsoft systems doesn't have consistency in terms of alerts on rotation. If you're using Azure Storage, you can say to Azure Storage and say, alert me if my key is older than this age. But it's only Azure Storage that has that capability in it. So I would love to see Microsoft introduce that across any service in Azure that supports long-lived access keys. So enable private link and VNet integration as a second line of defense so that if those were to be compromised, you'll still be protected. So I'm looking at the time now, and there's something else that I want to talk to you, and I have a nice demo that I wanted to show you on this one. So just give me 5 more minutes and I'll do this. I'll show you the demo and I'll stop. So the other thing that I learned from the vulnerabilities is that runtime protection is still important. Because what has happened is that as we begin to transition to the cloud, in order for us to achieve ease of use, in order for us to be able to achieve speed, in order for us to be able to achieve reduced management costs, the price that we've paid is less visibility. Like in the case of Azurescape, where the team were running an outdated version of RunC, and we had no visibility until a security researcher decided to use a tool to enumerate the runtime environment and saw that it was running an outdated version of RunC. So we have less visibility as part of that. But because of that, what I'm saying here is less trust. It's not as if no trust, but maybe the way to put it is say trust, but still protect yourself. So when you're using services like managed runtime environments, like functions and app service, wherever possible, where you can have that extra level of runtime protection embedded in your application, it's still good to do that, so that in case those kind of vulnerabilities happen again, if somebody were to try to run some code in your environment because they were able to exploit the service provider's misimplementation or misconfiguration, they were able to exploit that, you will still have some level of protection that will allow you to say somebody is trying to run some code in your environment that they should not be able to run. So it's still important. So even though it's a managed environment, and you don't have visibility, still look for ways to protect yourself and have a way to implement runtime protection. That could be using technologies like RASP and embedding runtime security into your code itself. So that's still important. The example I was going to show you was on Azure Container Instance. So right now, if I go over to this environment, so apologies, I wasn't able to show this to you, but hopefully I'll be able to show this next one to you. So I have an Azure Container Instance that's running an application that's compromised, that's vulnerable. So if I go to my Azure container environment, let me quickly authenticate to that. And so what I have here is I have two container instances running on Azure, one of them without runtime protection and one of them with runtime protection. So if I go to container instances there, I have this one without runtime protection embedded, this one with runtime protection embedded. So even though they are, I don't have underlying control of that, I still have runtime protection embedded into that. So now I want to show you what that looks like. So if I go back to this environment here and I connect to the one that does not have runtime protection embedded into that, and I'll quickly connect to it. I'll put in the credentials. So I'll do that off screen. So in the credential for that. And I just put in the credential for that. So let me go ahead and clear the screen. Clear. Okay, so let's do that over here. So now I'm connected to that. Let me go ahead and just do remote code execution and run that on that container instance. And I'm able to get to that. I'm able to see like the files that it's included in that environment. I can begin to even get environment variables. So by looking at the environment variables on this environment, so if an attacker is able to exploit like a service provider misconfiguration there on the environment and they're able to run code in your environment, they can see just by looking at this environment variable that this instance has a managed identity associated with it. So you can see identity header, you can see identity API version. So that means it has a managed identity. That means there's potential to be able to steal a token from this service that's running this application. And then an attacker can just proceed and get some tools installed, maybe even just get remote shell. So let me see if I can get a remote shell to this environment. So what I'm going to do here is I'm going to do this. Let me go to open a listener. So let's go to open a listener on this environment. Oh, not that. Let's do that again. So open a listener on this environment. And I'm going to open a listener for port 4444. So that's listening to any request. So I'm going to go to I'm going to go call out the container instance, and I'm going to get it to to open a reverse shell for me. So I'm going to do that by using this piece of code right here. And as I run that, you may not have noticed, but what it did was it opened a remote shell. So now I'm on that container environment. I can begin to poke around, look for the managed identity that it has, look for who am I, look for the credential that I have, see what type of access that I have. And this is on an Azure container instance, by the way. So, and I can begin to look at that. So, but this is an instance that I don't have underlying control of the environment, but I have another environment here. So let me go ahead and exit out of this. I have another environment where I have runtime protection embedded even in an Azure container instance environment. So let me go ahead and connect to that. So I'll connect to that instead. So that's called, I'll call that URL protected. And I'll go ahead and connect to that with my credential. And I'll go ahead and connect. Yeah, so that's connected. So let me bring that back onto the screen. And what I can do is if I go to run that, so you can see that the attack is still successful and stuff. That's because I've not implemented runtime protection, even though I have the protection embedded. So what I'm going to do is I'm quickly going to go to the environment where I have where I can configure my policies. So I'm going to go do that right now. So it's taking a short while. It's just authenticating me, sorry. So I'll go to the environment now. Come on, come on, come on. Okay, so it's authenticating me now. So what I'm going to do is I'm going to go to implement my runtime protection. And if I go to under defend, and if I go to under runtime, so I've embedded that into the application itself. So I can go add a rule, and I can call this Azure Container Instance Protection Rule. I can scope it based on any scope that I want, but in this case, I can really, in an ACI environment, I can define the processes that I want to allow are the processes that I do not want to allow. Even in an ACI, in an ACI environment that I don't manage, I can do this for Azure Functions, I can do this for Azure App Service. So if I put in that process there, because that's the process where my application exists, and I can say that's the only thing I want to allow. And I can say anything else I want to prevent, anything that's not part of the allowed process. So even if an attacker was able to compromise some other way and get to the environment, and they begin to try to run some code to enrich the environment, that's not going to work even in a managed service. So I can do that for also like the networking process, but I'm going to leave that for now. I'm just going to do that for the processes, and I'm going to save that. So now that that's saved, if I want to monitor what's going on, if I go to under monitor and events, I can go monitor what's going on under app embedded. So what I'm going to do is I'm going to run the same command that I ran just now that was successful. If I go ahead and run that again, so I was able to list the environment variable just a minute ago. If I go ahead and I run that again, and let's see. Oh, am I in the right environment? Maybe not. Maybe I'm not in the right environment. Oh, okay, I can see what I'm doing. So sorry, I'm in the wrong environment. Let me go ahead and do that in the right environment. Let's go ahead and do that in the right environment. So I'm going to do that. So that's logged in protected. It's the environment I want to be on. And if I go ahead and I run that, okay, let me go ahead and log back into that environment. Sorry. Now, actually, I can see that something happened just now. So let's run that again. Yeah, there we go. So something happened. So I can see that I run that. And if I run this, and you can see that I get no reply back. And instantly it flagged that to me to say in your container environment, someone was trying to run that to list the environment variable, someone was trying to run list in your environment, and I prevented that from running in that environment, and it's going to flag that to me, and I can go check the forensic, and it's going to collect the forensic of exactly what happened, even in an Azure Container Runtime environment. So that's something that's still important, especially as more attackers begin to focus on cloud providers to look for vulnerabilities in that sense. So in conclusion, follow those 3 lessons, right? So make sure that you go check your environment, make sure that you normalize private network access for platform services, make sure that you disable key-based authentication, local authentication where possible, and do not use them, and centralize that and monitor for usage across your environment. And number 3, wherever possible, even if it's a managed service, make sure that you still have that last layer of protection in terms of runtime defense. So I'm going to stop there. So hopefully you got 1 or 2 things. So apologies, I had to rush some of that, but hopefully you got a few things. So I'll take any questions if anybody has any questions.
Well, thank you, David. This has been really excellent. So we do have some questions here, and Mike P, do you was it Mike P? Do you want to come off and ask your question live here?
Yeah, thanks for that. I wanted to ask if you had any go-to tools for misconfigurations in Azure. Anything that's comprehensive that will enumerate all the different misconfigurations or common misconfigurations.
Yeah, Azure Policy is awesome for that. Azure Policy is awesome and it's free. However, it involves a lot of work that you have to do, right? So because Azure Policy is embedded into the control plane of Azure, it's embedded into HAM. So there's really nothing that you cannot access. You can access any configuration and you can do that 0 day. Like if Microsoft releases a new feature, you can begin to access it using Azure Policy. So Azure Policy is awesome for that. There is a tool that was written by Ian McKay. Let me see if I can find the link to that too, that you can sort of leverage in terms of Azure Policy. So Ian McKay, Azure Policy. Oh, maybe no, sorry. I think it's Brian Kilmed is what I'm thinking about, not Ian McKay. Sorry, it's Brian Kilmed. Yeah, you know what? Why don't we do this? Is it possible? Can you connect with me on, like, let's say on LinkedIn or on Twitter, and I'll get the link that I'm thinking about and send that to you.
That's great. Thanks so much.
Yeah, no problems. And then, so the other thing would be, so either you go down the route of Azure Policy, which is free, you have to put in some work to begin with, but you know, it has its own advantages. Or you can go down the route of looking at maybe a CSPM tool that you purchase. So there's cloud security posture management tools that does the same thing. So like the tool that I was just using right now is a tool created by Palo Alto. It's called Prisma Cloud. So it has CSPM capabilities. So some of them goes beyond just looking at the resources and looking at some of those use cases. Some of them goes beyond that to look at how your identity is structured. So for example, you know, we didn't even really touch on like even Azure AD because there's a lot of misconfiguration in that outback process that people can do. You know, there's one that came to my mind is, you know, you give somebody permissions to be able to list keys, right? They can escalate privilege easily with that permission. So yeah, so some of them goes beyond like just the native resource misconfiguration to looking at identity misconfiguration. So, but those are paid for. So it depends on if an organization has budget for those. So things like, again, tools like Prisma Cloud would be good. But as a start, Azure Policy is awesome.
Thank you for that, David. If you share that info with me as well, if you come up with the link for Mike, I can share it with the community generally. Lucas, do you want to come off and ask your question?
Sure. Just wondering if we could get a copy of the slide deck. So much good info in there. Just to review my own Azure environment would be great.
Yeah, I'll do that. So I'll convert that to PDF and I'll send that over to Bill. So Bill, I'll put it on GitHub and I'll send you the link.
Perfect.
Awesome.
Thank you so much.
So I'm just making a note of the action that I need to take. So,
do we have any final questions for David before we do the raffle? Okay, Veronica, do you have a scheme for the raffle?
I don't, but I'll come up with something. Okay, my idea, I was thinking about it a lot. I actually have a list of all the attendees. They are in alphabetical order in teams. Unfortunately, there is no way to remove from that list Bill, Jason, myself, and David. But if for some reason anyone from the shorter list of organizer gets selected, then I'll regenerate a random number. So I am gonna share my screen so you know that I'm not just making up numbers here.
And while Veronica's doing that, David, I know it's past midnight for you. I'd like to. You should feel free to go to bed. We'll thank you so much. This is a really engaging talk. I've been working in Azure for 11 years or so, and I learned a bunch of stuff. So it's really, really well put together, very thoughtful. So appreciate you sharing the knowledge, and maybe we can have you back in 2022.
Yeah, no problem. Really appreciate that. Thanks very much for the invite also. And I'll get the information I promise. I'll get those over to you. So yeah, no problem. So yeah, thanks very much, everyone. I'll see you later. Thanks. Bye for now.
Thank you, David.
Thank you. Bye.
Back to you, Veronica.
Yes, thanks, Bill. So yeah, I didn't mention what the prize is, the most important part. So the prize is actually a $50 gift card for an online swag store. It is actually from our New Hampshire friends. New Hampshire Code Camp provided the gift card. So thanks to them. It was a great event. I was really happy to participate and see Bill there in person. Okay, so let's go back to the main part. Currently, we have 24 people in their participants list. So I'm gonna generate a number. It is 23. Let me see. So it should be Tony. Tony Guest. I don't know what the last name is. Tony, can you please unmute yourself or somehow let me know who you are? Okay, Tony. Okay, great. So Tony is here. Tony, please reach out to me offline. I mean, not offline, but offline of this meetup through Twitter, through Slack if you are in our Slack, but if not, my email. You can use that too. I'm going to post it in the chat. So just email me your information and I'll forward you the code. And thanks everyone for joining us. That's the last event of 2021. And we are really excited to see you next year, I guess. Bill, back to you.
Thank you. Yeah, everybody have a great holiday. Be safe. And like Veronica said, we'll see you on the other side of the new year. Good night, everybody. And this YouTube recording will be up usually tomorrow, usually next day on youtube.com/BostonAzure. Over and out. I'm signing off for the night. Thank you.